Hey everyone, this is Mrs. Miller again, and I am really excited about this lesson because I am going to talk to you about how your body fights off invaders. And I think that this is just one of the most amazing examples of our body working to keep us safe and to maintain our homeostasis. So let's get started. So the first thing that we need to make sure we do is define disease. What is a disease? A disease is anything that disrupts the body's normal activities and anything that disrupts the normal functions. A pathogen is anything that causes a disease, and this can also be referred to as what's triggering the immune response. Okay. Some examples of pathogens we've already been talking about a lot. We can have bacteria, we can have viruses, we can have protists. So we've talked about examples of some of these diseases, and in our last lecture I talked to you about the difference between viruses and cells. And it can also be fungi. Okay, we've talked about some examples of diseases of fungus, fungal infections. Pathogens can also be your own cells. When this happens, it's called an autoimmune disease. And this would be when your own cells are triggering an immune response. We're going to talk a lot more about that in another video. So let's take a look at some of the ways that you can get sick. So obviously, pathogens can be transmitted through physical contact. And this is one of the things that we're very familiar with this year, right? We've done so much to try to reduce the amount of physical contact that we have. This means that you come into contact with infected bodily fluids or touch someone who is infected, depending on what kind of pathogen or disease they have contracted. This could be sharing a drink with somebody. It could be being in a crowded elevator and somebody who's sick sneezes, any of those. We can also get diseases from infected animals. Tick bites, mosquito bites, things like that can transmit disease. Rabies is transmitted by infected animals. And then one of the more common ways that people get sick is through contaminated food or water. We talked a lot about how E. coli is often spread through improperly handled food. And then contaminated drinking water is unfortunately much more common even here in the US than we would think. Right now, some cities in the state of Texas are under boil water orders because their water is not safe to drink. And that can transmit some really nasty pathogens. So let's look at your immune system. Your immune system basically has 3 lines of defense. The first line of defense is sort of like the exterior wall, around a palace or around a compound. And it's really there to keep everything out. Everything, whether it's a good thing or a bad thing, the first line of defense is what we call non-specific. And so it does not distinguish. The second line of defense is what comes along after the first line has been breached. So a pathogen has been able to get through that wall. The second line of defense comes along. And then finally, we have the third line of defense, and this is the cellular level. And so you see here some blood cells and some white blood cells. So let's start off by talking about the first line of defense. So this line of defense is what we call non-specific. And what that means is it doesn't discriminate. The first line of defense will work to keep everything out, whether it is pathogenic or non-pathogenic. And so these are what we want to call the barrier methods. So we have the skin, which its job is to act as a natural barrier to prevent anything from getting inside. But we also have other external factors that can help. We have the cilia and the mucus inside our nasal passages, and that's designed to trap anything that kind of gets into your nose. And that's why, if you're cleaning out your room or something and you stir up a lot of dust, if that dust gets into your nose, you're going to get that kind of runny nose and you're going to sneeze because all of that is being trapped in your nasal passages and then forced back out. Your tears actually contain enzymes that can help break down the walls of bacteria. The same goes for your mouth. In your mouth, there is saliva that is acidic, and it also contains enzymes to help break things down. And then finally, this is actually internal, but your stomach acid is actually a part of this first line of defense. If you were to, let's say, inhale some bacteria cells or some virus particles, if they were to make it into your stomach, most of those pathogens are actually destroyed by your stomach acid, and they never make you sick. So that's the first line of defense. The second line of defense is also non-specific, and this is called the inflammatory response. Now, when I post these slides onto Google Classroom, you will be able to click this link here and watch a little video that talks a little bit more about the inflammatory response. I'm just going to kind of describe what you're seeing here. So inflammation means to swell. So anybody who has gotten a mosquito bite or who has fallen and gotten a bruise or scraped their knee has experienced this inflammatory response. So this is what happens when the surface of the skin is broken. So the pathogen has been able, or sorry, not the pathogen, but just anything has been able to get past that first line of defense. The same thing happens when you get things up into your nose or you get things in your eyes, you get swelling and running and of the mucus and things like that. So let's say that you get a splinter. Okay, that's what this is right here. This is your skin, and then here is the opening. What's going to happen is your blood vessels are going to dilate. That means they're going to swell. All right, and when they swell, that allows white blood cells to come through openings in the blood vessel so that they can get to the injury site. And they will begin to engulf anything that doesn't belong. We talked about this a little bit in our homeostasis unit when we talked about a positive feedback loop, because what this is also going to do is trigger an increase of blood flow to the area. This is why if you've ever gotten a bruise, you know how sometimes you might like hit your arm on a table or bump into a chair or something, and it hurts for a little bit, but you don't see any marks. And then maybe the next day you have just this giant, ugly bruise. That is a result of this inflammatory response, because maybe right at the moment, it's not necessarily hurting. And even then, you know, if you have a bruise, you haven't necessarily broken the skin, but your body doesn't necessarily know that. Because again, this inflammatory response is non-specific. It's going to happen anytime there's an injury because of the possibility that an infectious agent could have gotten in. And so that's why you sometimes see that, you know, swelling maybe a day or so later, because the inflammatory response has just been working all night. Okay. So what happens in the inflammatory response? Well, we have a few key defenses. We have what are called phagocytes. These are white blood cells that will engulf and destroy pathogens. We also will get a fever. A fever plays a couple of roles. So part of the role of a fever is just to crank up the temperature. If you remember from our unit on organic compounds, we talked about how enzymes have an optimum temperature. And if they are exposed to temperatures that are either above or below that optimum, they won't work. They become denatured. And so a fever is actually your body's way of trying to sort of crank up the temperature to slow down any pathogens that might be inside. But it's also a good way for your body to signal that you need rest, because what's happening during this inflammatory response is your body is fighting a battle and it needs all the energy it can get. And so you're going to feel tired when all of this is going on. And then finally, we have something called interferons. And interferons are proteins that are produced by cells that have been infected with a virus to help other cells resist the infection. It's almost like if one cell becomes infected, it will display the virus particles as a way of sort of warning other cells, you know, like, oh, I let this guy in and he tore my house up, so please don't let him into yours, okay? All right. So what happens if the first and the second line of defense have been breached? We have several cells that are involved in the third line of defense, the immune response. They are the macrophages, the helper T cells, the B cells, the antibodies, the killer T cells, the memory B cells, and then the suppressor T cells. So let's look at these, okay? So when you are sick, this is the pathogen has made it past the first and the second line of defense, and it has started destroying cells. All right. We've talked in the past that, bacteria and things like that don't actually make you sick. You don't start to actually feel sick until your cells begin to die. And this is why it's so important, especially now, we're talking about COVID and how so many people can be infected with this virus, but not show symptoms of it until, 2 or 3 days post-infection. Well, even if they're not showing symptoms, that virus is actively replicating inside their cells and causing destruction, and it's possible to spread it. So that's why some of these responses that we have taken to try to protect all of us from this virus are so important. So there are really two ways that this can happen, and we're going to talk about both of them. So there's what's called the humoral immune response, which is also known as antibody-mediated. And then there's also the cell-mediated antibody response. Now, this is a really big graphic, and I don't expect you to memorize this or anything. Really, what we're going to talk about is just sort of the general order. So let's take a look. Let's start out by talking about the cell-mediated immune response, okay? So this little visual here just shows us that the first step is going to be that a cell called a macrophage, and here it's called a phagocyte, is going to engulf our pathogen. And the reason that I think that this visual is important is because it shows us those antigens. Now, I've said the word antigen before, and now is when it's going to become very important, right? An antigen is a marker on the surface of the cell that identifies it. So every cell in my body has an antigen that it identifies it as belonging to me. And anytime something gets inside my body that doesn't have my antigens on it, my immune system is going to recognize that, and it's going to go on the defensive. So the phagocytes, the macrophages, engulf the pathogen, and then they begin to display the antigens on the surface of their cells. Those macrophages are then going to go and find a T cell. And then those T cells can go to work destroying the cell. I'm going to go into a little bit more detail on that right now. So let's look at the macrophage. All right. So macrophage almost literally translates to big eater. So that's its job. It engulfs and destroys pathogens. It has little enzymes inside it that will break them down. But the other really important thing that it does is it displays those antigens on the surface of its cell. It's carrying them around almost like a trophy, right? It's like, I have killed this, and here is what it looked like. So then those macrophages are going to bind to a cell called the helper T cell. So when they bind to that helper T cell, what they're doing is they're showing that antigen to the helper T cell and saying, this is the enemy. This is what we need to look for. And then the helper T cell is going to get to work. The helper T cell actually signals and activates all of the other cells in the immune response, okay? So now I'm going to just take a quick break and say that this could also trigger what's called the humoral immune response, which is going to involve B cells. So let's talk about what those do. The B cells, once they recognize that antigen, are going to produce proteins called antibodies. Now, this is something that I've talked to you about before. Antibodies have the job of binding to and disabling pathogens. You remember I showed you the video of Mr. Incredible and how when he was captured in Syndrome's lair, all of those big bubbles stuck to him and he couldn't move anymore. And that's what antibodies do. They stick to the pathogen so that it can't move. And then some other cells can come along and destroy them. And those cells are called the cytotoxic or killer T cells. And they do exactly what their name suggests. They destroy the pathogens, and they also go along destroying any infected cells. And both of those are important. But this is also why, if you've ever had the flu or anything like that, one of those things that happens and one of the things that lingers for a really long time is that you have a really sore throat. And that's because not only has the virus destroyed throat cells, but these killer T cells are going in and destroying cells. The other thing that's really important, and this is part of that humoral antibody or that humoral immune response, is that there are memory cells. Your body produces memory B and memory T cells, but we'll just worry about the B ones. And what they do is they remember that pathogen so that anytime you come into contact with it again, you don't have to go through the long chain of command. You don't have to go through cells getting destroyed and then macrophages and then helper T cells. If a memory B cell recognizes that antigen, it's going to immediately get to work producing antibodies. And what happens is you may not ever feel sick the second time you get exposed to a pathogen. The final part of an immune response is the suppressor T cells. And suppressor T cells, again, do exactly what the name suggests. They suppress or stop the immune response. These are the cells who are responsible for sort of turning off the response. Because again, if you think about it, you've got your B cells producing antibodies that are sticking to these pathogens, and then you've got your killer T cells that are going along and they are destroying not just pathogens, but also infected cells. We have to stop that response. Remember, this is a negative feedback loop, right? The response is eventually going to bring us back to homeostasis. So the suppressor T cells are what sort of sound the all clear, that everything is fine and the battle is over. And this is where you're going to start to feel better after you're sick, okay? Now, one thing that I already mentioned, and that is this idea of the memory B cells. Now, we have different responses depending on our level of immunity. So we have what's called the primary immune response. And in that case, what I've got here is the first time that you're exposed to a pathogen, the production of antibodies is going to be pretty slow and pretty low. It might take your body a long time to sort of fight off that infection, and you're not going to produce very many antibodies. As time goes on, because of those memory cells, if you get exposed a second time, look at what happens to our antibody production. It goes way up. And that's because of those memory cells. Those memory cells stay around for a long time. It varies depending on the pathogen, but a lot of us have almost permanent immunity to a lot of pathogens out there. And that's why, for example, you don't get the chickenpox more than once, or most of us don't get the chickenpox more than once, because that first exposure is enough to produce the memory cells to last us most of our lives. All right. So how do we get immunity? There are two kinds of immunity. There's what we call active immunity and passive immunity. Active means that you produce those antibodies on your own. And what that means is that you either naturally are infected with whatever the pathogen is. So let's say you get the flu and then you get better. Your body will produce those antibodies, and then you will have memory cells to remember that virus for all time. Artificial immunity is when you are exposed to a form of the pathogen and you produce those antibodies afterward. So a vaccine, there's a lot of misunderstandings around vaccines. Vaccines don't actually give you an infection. What they do is they introduce your body to the antigen that is on the pathogen. Not all of them. There is a little bit of difference with the mRNA vaccine. That's what this COVID-19 vaccine is, and more on that a little bit later. But the key is that they're not really giving you the pathogen. They're just introducing your body to that antigen so that your body can go ahead and start producing antibodies. And this is why some of us, after we get a flu shot, tend to feel a little bit sick after we get that shot. That is a sign that our immune system is working. Because what's happened is your body has recognized that there's something that doesn't belong, and it has triggered an immune response. And for some of us, that immune response is a lot bigger than others. And that's why, for me, I have gotten flu shots every year, and sometimes I feel fine, and then other times I have to take a day off because I just really don't feel well the day after getting that shot. And it really just varies from year to year, depending on the strain and depending on your own immune system. Now, passive immunity means that the antibodies are given to you. And these can be conferred two ways. So natural in this case is from mother to child. A mother can transfer antibodies to her child through her breast milk. She can also transfer her antibodies through the placenta during gestation. And this is why when women are pregnant, they are recommended to get several vaccinations. For example, the pertussis vaccination. Pertussis is a disease called whooping cough, or commonly known as whooping cough, and it can be fatal in babies. And so most pregnant mothers will get that vaccine so that they can begin transferring those antibodies to their child even before they're born. And the same is true of the flu shot. It's basically giving the baby, some natural immunity when they're going to be born, basically without that fighting immune system. They have to develop that as they get older. The other type of passive immunity is one where a person is given antibodies. What this means is if a person gets sick with a virus or a bacteria or whatever, and they get better, they have antibodies in their bloodstream. We can take those antibodies, we can purify them, and we can give those antibodies to another sick person who maybe hasn't produced the antibodies yet. And those antibodies can then help them start to fight off that infection. This is a treatment that they have used in fighting Ebola, and it's also a treatment that they're using in fighting COVID-19. The antibody treatments have been very helpful in helping people to fight off disease. That is all that I have for the immune system. Make sure to check out your concept check, and I'll be posting lots and lots of videos and some vocab to kind of help you make sense of all of this. And I really hope that this helps out. If you have any questions, please don't hesitate to ask me. This is one of my favorite topics. I love talking about it. Y'all have a great day.